This is a train station, and it might be the single most absurd construction project you will see all year, because engineers took an actual mountain, cut it flat, and then built the largest train station on planet Earth directly on top of it in just 38 months. And if that number doesn't stop you yet, stick around, because most countries take longer than 38 months just to approve the paperwork for a project like this, and China simply built it. 2 million cubic meters of concrete, 366,000 tons of steel, 40,000 workers moving in perfect coordination across a single mountain slope. This is Chongqing East, and by the time this video ends, you will understand exactly why nothing about this building was supposed to be possible. The finished structure rises 41 meters into the sky, shaped deliberately after the city tree of Chongqing, wrapped entirely in 1,200 individual stainless steel scales that catch the light differently depending on the hour of the day. And before engineers ever poured a single column, before a single beam went up, workers had to do something almost nobody outside the industry ever thinks about. They had to cut an entire mountain flat, because this station never once sat on level ground. It sat on a slope, on solid rock, on a hillside that had to be forced into submission before anything else could happen. To put the raw scale of this building into perspective, Grand Central Terminal in New York is roughly 6 times smaller than this single station. Europe's largest train station is still 15 times smaller by comparison. Individual platforms here stretch beyond 400 meters in length, meaning the trains arriving at this station are physically longer than the Eiffel Tower is tall. Rewind back to April of 2022, and this entire site looked like nothing more than an ordinary mountain slope, roughly 20 kilometers outside downtown. Chongqing, a city so famously chaotic in its layout that locals proudly call it the 8-dimensional city, a place where elevated roads run directly above your head and high-speed trains pass straight through the base of residential apartment towers as a matter of routine daily life. A train running through the middle of a building is considered completely normal here, and honestly, that single detail tells you everything you need to know about the mentality of the city that eventually built Chongqing East. This, in every sense, is next-generation infrastructure thinking. In April of 2022, heavy machinery finally moved onto the site, and step one of this entire project was almost comically blunt: cut the mountain flat. Every single meter of that original slope was mapped in exhaustive 3-dimensional detail before a single cut was ever authorized, because on a mountain job like this, there is simply no room for assumptions. The earthwork phase alone consumed months of continuous effort. The underlying rock beneath Chongqing is notoriously hard, dense, and stubborn, so machines ran around the clock without pause, day shift bleeding directly into night shift. Some sections of rock were simply too dense for mechanical excavation alone, requiring carefully controlled blasting, precise explosive charges calculated to break the mountain apart without damaging the surrounding structure. The mountain, quite simply, did not give up its rock easily. This became one of the largest single-site excavations in the entire history of Chinese construction, with millions of cubic meters of solid material physically removed from the landscape, all of it in service of one single goal: a genuinely flat platform where none had ever naturally existed. Once that rock face had finally been cut back, engineers immediately faced a new problem, because a freshly cut mountain slope wants nothing more than to slowly reclaim its lost ground. Retaining walls were installed along the entire perimeter of the excavation, holding back the surrounding earth permanently. And there was another invisible enemy working against the crews the entire time. Every single drop of rain that fell on the mountain slope above the site flowed directly down through the exposed ground toward the construction zone below, and without a properly engineered drainage system in place, the entire foundation would eventually be sitting on nothing but saturated, waterlogged soil, a foundation destined to fail. Excavation, blasting, retaining walls, drainage, layer after layer of invisible preparation just to create one flat platform on the side of a mountain. Only once all of that groundwork was fully complete did the actual construction of the station finally begin. Even then, before the very first pile was driven, engineers tested the ground extensively, because on a site built entirely on a reshaped mountain, there is no such thing as a safe assumption about what lies beneath your feet. By the time all of that testing wrapped up, the site preparation was finally genuinely complete. The mountain had been forced flat. Drainage systems were fully installed. The ground itself had been thoroughly tested and understood. Now, finally, the true foundation work could begin. Massive piles were driven straight through the surface layer and directly into solid bedrock beneath it. Because every single floor of this eventual 8-story structure, every ton of concrete, steel, glass, and human weight above it would ultimately transfer its entire load down through these hidden piles and into the mountain itself. Hundreds of individual piles were driven using multiple drilling rigs working simultaneously across the site, because the true foundation of this building isn't one single pile. It's an entire buried forest of them. Inside every pile, a rebar cage was carefully lowered into place before any concrete was poured, because without that internal steel reinforcement, a pile only possesses compressive strength, roughly half of what the finished structure actually requires to stand safely for decades. Concrete itself was poured from the bottom upward through a specialized tremie pipe, a critical technique because if you simply pour concrete straight down from the top of a deep pile shaft, the heavier aggregate material sinks unevenly, and the resulting pile ends up dangerously weak. Every single completed pile was then load tested individually, because discovering a structural failure at this early stage is enormously cheaper and safer to fix than discovering the exact same failure hidden underneath a fully completed 8-story building years later. Some of these piles were driven 20 full meters into solid bedrock, yet from the surface, you can only actually see about 30 centimeters of any given pile head, meaning the remaining 19 meters and 70 centimeters of each pile sit completely invisible underground, silently carrying the enormous weight of everything built above them. Across the site's full 1.2 million square meters of footprint, hundreds upon hundreds of individual pile heads exist, and yet the entire foundation network remains completely invisible, once construction is finished, buried beneath the surface forever. On top of these piles sit specially engineered pile caps, structures designed specifically to distribute the load from each column across multiple piles at once. Because no single structural column in this building actually rests on just one pile, every column rests on an entire coordinated group of them working together. Ground. Beams then tie every single pile cap across the site together into one unified structural grid, meaning any load placed anywhere on the site gets automatically shared and distributed across the entire underlying network rather than concentrated dangerously in one spot. From there, construction of the first floor slab began, formwork installed, rebar tied, concrete poured, and this exact same sequence was repeated 8 separate times to eventually reach the very top of the structure. In blistering 40-degree heat, workers spent entire shifts tying rebar by hand while wearing full protective gear, floor after floor, pour after pour, in conditions that would exhaust most people within minutes. Curing concrete naturally generates its own internal heat as a chemical byproduct of the hardening process, and in the brutal Chongqing summer climate, that trapped internal heat can actually crack a concrete pour completely from the inside out if left unmanaged. So engineers embedded cooling pipes directly inside the concrete itself, specifically to prevent that kind of catastrophic internal failure. Every major pour was executed as one single continuous operation, because stopping partway through creates what engineers call a cold joint, an inherent structural weakness baked permanently into the finished concrete. Concrete delivery. Trucks arrived at the site in an unbroken stream without pause, feeding each continuous pour exactly as needed. The soaring's 41-meter columns you eventually see standing in the completed station all technically began their existence right here at ground level, built one modest section at a time. Rebar cage, formwork, concrete, curing time, formwork stripped away, and then the entire sequence repeated, again and again until each individual column finally reached its full towering height. By the time 5 full floors were completed, the platform levels, the underground metro connection, and the ground level bus and taxi concourse were all functionally in place, with 3 additional floors still remaining to be built directly on top of them. The 6th floor became the building's main concourse, the single largest open interior space in the entire structure, constructed a full 30 meters above the original mountain slope below it. The curved edges of that massive concourse floor had to be engineered with extraordinary precision, because if the concrete slab edge was cut even slightly wrong, the enormous glass curtain wall designed to enclose the space simply would not fit correctly once installed. Every single one of those sweeping curves was carefully hand-formed on site, rather than mass-produced. The 7th and 8th floors above that were dedicated to retail shops and restaurants, effectively layering an entire functioning city district directly on top of the transportation infrastructure below it, using precisely the same repeated construction sequence as every floor before it. The 8th floor ultimately marked the very last poured concrete slab in the entire structure, and once that final slab cured, the project pivoted entirely, because from that point forward, the steel columns would begin their dramatic rise. With all 8 floors finally complete and standing open to the sky above, the roof itself had not even begun yet, but the essential underlying structure was firmly and completely in place. The signature 41-meter steel columns technically began right at that 8th floor level, rising directly upward into open air above the finished concrete frame below. 366,000 tons of raw structural steel arrived continuously by road, sorted meticulously by crane operators, staged and ready to be lifted into position. The very first steel sections rose directly above the completed concrete structure, growing steadily skyward toward a roof that, at this stage, technically didn't exist yet anywhere on the site. Each individual steel section measured roughly 6 to 8 meters in length, installed one careful piece at a time, bolted firmly into place, checked meticulously for plumb alignment, and only then followed by the next section above it, repeating that exact same sequence all the way up the entire 41-meter height of each column. Every single structural splice connecting these sections together had to conform to the exact same rigorous engineering specification, because a single completed column section would eventually carry a share of the roof's full 16,500 tons of weight, meaning every individual bolt mattered enormously to the overall structural integrity. With 40,000 total workers on site, construction never proceeded one column at a time in isolation. The entire forest of steel columns rose together simultaneously, with dedicated cranes positioned at virtually every single column location across the site at once. Near the very top of each column, the structure begins to visibly branch outward, transforming from a simple vertical shaft into something resembling the spreading limbs of the Huangju tree the entire building was designed to evoke, with additional branching connection points specifically engineered to distribute the roof's enormous load more evenly across the entire supporting structure. Specialized crews fitted the decorative steel scales starting from the base of each column, while separate crane teams simultaneously lifted additional structural sections into place higher up, meaning two completely different construction operations were happening at once on the very same column. Each individual stainless steel scale measured just 3 millimeters thick, with 1,200 of them ultimately fitted by hand onto every single finished column across the entire site. Seen side by side, the difference between a bare, unfinished steel column and its fully scaled, finished counterpart is genuinely striking, the exact same underlying object. Yet one represents what structural engineers built for pure function, while the other represents what architects specifically designed for visual identity. Workers could be found simultaneously fitting these individual scales at heights of 5 meters, 20 meters, and 35 meters, all working on the exact same column at the exact same time. Eventually, every single column across the entire site was standing complete, with all of the distinctive branching tops fully ready to receive the roof structure above them. The entire forest of finished steel columns now visible and complete, still with absolutely nothing covering it from above. Every individual column head was carefully verified for precise alignment, because if a single receiver plate sat even a fraction of a millimeter out of position, the enormous roof truss simply would not seat correctly once lifted into place, and there would be no opportunity whatsoever to make adjustments once that massive structure was already suspended in the air. From base plate to column top, each finished column measured a full 41 meters, wrapped in 1,200 individually hand-fitted steel scales, and even after all of that, the roof itself still had not been started. 8 complete floors of concrete construction, 41 meter, steel columns standing fully complete. Still no roof anywhere on the entire site. This particular stage of construction is genuinely the most visually dramatic moment in the entire build. The bare structural skeleton standing exposed to the sky, completely stripped of any outer skin whatsoever. Remarkably, the roof itself was actually assembled almost entirely at ground level rather than up in the air, because you simply cannot build a 16,500-ton structure piece by tiny piece while suspended 57 meters above the ground, so engineers instead built it low, close to the earth, and only then moved the completed sections upward into their final position. Every single structural bolt throughout that entire ground-level roof assembly was torqued to exact specification and individually marked complete, because leaving even one under-torqued bolt anywhere within a 16,500-ton roof structure would be completely unacceptable from a safety standpoint. A dedicated rail system was installed, running at column head height, specifically to support the roof's eventual journey upward, because the entire massive structure would be raised just once and then slid horizontally into its exact final resting position. Multiple heavy cranes worked together to lift the assembled roof steadily upward toward its full 57-meter target height, with ground crews guiding the entire delicate operation using nothing more than carefully practiced hand signals. The tolerance required for the roof to correctly land on its supporting rail system was measured in mere millimeters, and engineers rehearsed this exact lifting sequence repeatedly for weeks before ever attempting the real, irreversible lift. Massive hydraulic jacks slowly inched the structure 10 meters, then 20 meters, then further still into its precise final position, effectively moving hundreds of tons of finished roof structure the way you might casually reposition a piece of furniture. Once every section was finally welded permanently into place, that particular portion of the roof belonged to the building forever, no longer a separate assembled piece, but a fully integrated part of the permanent structure. Hundreds of tons of steel roof structure moved slowly along overhead rails directly above construction crews working below, simply because no crane anywhere existed that was capable of lifting a structure this massive directly into place in one single motion, forcing the engineering team to essentially invent an entirely new construction method specifically for this one building, lifting each section low, sliding it carefully into position, and then welding it permanently in place, piece by piece, across the entire 120,000 square meters of finished roof surface. Workers standing on top of the completed roof structure at a full 57 meters above the ground could see the surrounding Chongqing mountain range stretching away in every single direction while carefully fitting the final stainless steel panels that would ultimately form the building's outer skin. Skylight openings were deliberately cut into the roof only after the surrounding panels had already been installed, with each individual elliptical opening precisely located according to the original architectural design. At 120,000 square meters total, this became the largest single-span roof structure ever built anywhere in China, supporting a combined structural weight of 16,500 tons. With the roof finally complete, the entire building was now fully enclosed from above, and everything that happened from this point forward would take place entirely within the finished shell. 1,200 tons of aluminum framing were installed throughout the structure before a single pane of glass was ever fitted into place. Each individual glass panel weighed roughly 800 kilograms, installed by dedicated crews working at significant height in the same relentless 40-degree summer heat, requiring hundreds of separate individual lifting operations to complete. Once finally installed, this enormous glass curtain wall effectively closed the building entirely, and with it, the surrounding mountain landscape flooded directly into the interior concourse space, exactly as the original architects had always intended from the very first design sketch. That same expansive glass regularly reaches temperatures above 60 degrees during the brutal summer months, while dropping below freezing during winter. So dedicated expansion joints were engineered throughout the glass structure, specifically to absorb that constant thermal movement, because without them, the glass itself would eventually crack under the repeated stress. While all 8 above-ground floors were steadily rising toward completion, a completely separate crew was simultaneously tunneling toward the exact same site from the existing metro network far below. 2 entirely distinct construction projects, effectively merging into one single finished building, with the metro connection point sitting a full 30 meters beneath the main concourse level, built entirely underground, while the visible floors above it continued rising toward the sky in parallel. That underground metro connection sits 30 meters below the surface, linked to the busy, high-speed rail platforms above by a single dedicated escalator, and that one specific connection point is genuinely why this entire transportation hub actually functions as intended, with every single metro passenger passing through this station eventually relying on those exact escalators to move between the deepest underground level and the busiest levels above. Before a single length of rail was ever installed, engineers first laid down the underlying track base with millimeter-level precision, because at operating speeds of 350 kilometers per hour, absolutely nothing about that foundation can be allowed to be anything less than perfect. Rather than using traditional loose gravel ballast, engineers instead used a slab track system bolted directly to solid concrete, a method that, once properly installed, never shifts, settles, or requires the ongoing maintenance that traditional ballasted track demands. Millimeter-precise alignment had to be achieved across all 29 separate tracks, all contained within a single building constructed directly on a reshaped mountain slope, with every single meter of rail laser checked repeatedly before final fixing. Thermite welding techniques were used to fuse the rails into one single continuous length, completely eliminating any structural joints anywhere inside the station itself. Overhead, catenary wires had to be positioned at precisely the correct height above the tracks, because if positioned even slightly too high, an approaching train's pantograph loses electrical contact entirely, and if positioned even slightly too low, that same pantograph suffers physical damage on contact. Wire tension naturally changes with ambient temperature throughout the day, so the entire overhead system was engineered to automatically compensate for that constant variation, with workers carefully calibrating the system across the full extreme range of Chongqing's seasonal temperatures. Every single platform screen door installed throughout the station had to align perfectly with the doors of arriving trains, meaning the train's own precise stopping accuracy was actually engineered specifically around these exact fixed door positions. Across the station's full 1.22 million square meters of interior floor space, roughly equivalent to 170 full-sized football pitches laid side by side, floor tiles were installed with completely consistent spacing throughout, every single tile positioned identically, a level of manufacturing and installation precision that no human construction crew alone could realistically achieve without specialized machine assistance. Without a fully functioning climate control system, that massive open concourse space would effectively become an unbearable greenhouse during the brutal Chongqing summer. So the entire HVAC system was specifically engineered and sized around the single hottest day ever recorded in the region's climate history. Thousands of kilometers of electrical cabling run continuously through every single floor, corridor, and platform throughout the building. And remarkably, this one station actually operates its own dedicated electrical substation rather than relying entirely on the surrounding municipal grid. A comprehensive fire suppression network stretches across the full 1.22 million square meters of the building, with a sprinkler system genuinely larger in total scale than the entire road network of some small towns. The building's LED lighting system automatically dims itself down to a safe minimum level whenever natural daylight floods sufficiently through the glass curtain walls and overhead skylights, while strict safety regulations still require a consistent baseline level of artificial lighting at every single hour of the day, meaning the system seamlessly compensates for changing natural light levels during both dawn and dusk without any noticeable transition. Rail tracks were being actively tested for structural integrity at the exact same time retail shelves elsewhere in the building were quietly being stocked for opening day, an overlap almost nobody visiting the finished station will ever notice or think about. Hidden service corridors running behind the visible walls contain HVAC ductwork as wide as an entire car, alongside electrical conduit, running for hundreds of continuous meters, all fully installed before. The surrounding walls were ever sealed shut. Before the very first test train ever entered the station, engineers meticulously measured the precise geometry of every track and platform, with every single deviation identified and corrected before the project was allowed to move forward into the next testing stage. Every individual signal throughout the entire station was tested first in complete isolation and then again in full combination with every other signal, specifically to guarantee that no two conflicting train movements could ever possibly be authorized simultaneously. After every single test run, engineers compiled a detailed corrections list, identifying issues, implementing fixes, retesting thoroughly, and repeating that entire cycle again and again until that list finally reached 0 outstanding items. Test trains eventually approached the station at speeds up to 200 kilometers per hour, meaning systems originally tested carefully at simple walking. Pace were ultimately retested at roughly 20 times that original speed under genuinely realistic operational load conditions. Every conceivable failure mode throughout the entire station was deliberately tested before a single paying passenger was ever allowed to board a train here, not necessarily because any particular failure was considered especially likely, but simply because leaving any single scenario completely untested was never going to be an acceptable risk. After a full 38 months of continuous construction, there still remained a lingering snag list of minor imperfections, with every single one of those small issues carefully corrected before the building was formally handed over, representing the final quiet act of an enormously loud and dramatic construction process. On June 27, 2025, this entire project officially transformed from architectural blueprint into a fully operating train station, having taken exactly 38 months from initial groundbreaking to opening day. On that historic opening day, the massive concourse stood completely full of passengers, the internal flow of foot traffic working exactly as originally modeled, escalators running continuously, and trains departing precisely on schedule. An actual airport check-in desk sits directly inside this train station, meaning passengers can check their luggage straight through to the airport before ever boarding their train, an integration genuinely operating live for the very first time that day. 8 full floors, every single mode of transportation connected seamlessly together, all of it running in perfect coordination for the very first time in the station's history. Every single night, after the last scheduled train departs, dedicated maintenance crews move across all 20. 9 tracks, working under conditions designed for trains running at 350 kilometers per hour, because ongoing maintenance at this scale and speed is never treated as optional. The soaring columns, the massive roof, the precision-aligned tracks, the underground metro, connection, and the enormous glass curtain wall, every single major construction challenge throughout this entire project is now quietly working exactly as intended, every single day. Just 3 months after opening, the station was already processing roughly 16,000 passengers every single hour, running precisely according to the engineer's original operational modeling. Those 1,200 individual steel scales wrapped around every column sit at subtly different angles from one another, meaning the visual appearance of each column genuinely shifts and changes throughout the day as natural light moves across it, and that visual effect was always a deliberate part of the original architectural design. The very same construction cranes that originally built this station were eventually relocated to begin building the surrounding urban district that continues rising around it today, because in projects of this scale, the station itself always comes first, with the surrounding city inevitably following close behind. Just 38 months earlier, this exact spot was nothing more than an undeveloped mountain slope, yet ordinary passengers moving through the building today never think about any of that hidden history. They simply know this is where their train happens to stop. 6 months after opening, every single connection throughout the entire station had been thoroughly checked and verified, with the overall conclusion from engineers proving genuinely better than even the most optimistic original projections. 1.2 million square meters of total floor space, 8 complete floors, 41-meter tree-shaped columns, a 16,500-ton roof structure, all of it built directly on a reshaped mountain slope in Chongqing in just 38 total months. 120,000 square meters of finished roof, with skylights carefully positioned to let the open Chongqing sky flood directly into the concourse below. Piles driven deep into solid bedrock, 8 full floors rising steadily above them, columns and roof assembled and slid precisely into position. An entire metro connection tunneled in from below, and the whole project opening exactly on schedule to the day. That is Chongqing East. An underground metro connection reaching all the way up to the busy high-speed concourse through a single dedicated escalator, quietly tunneled into place while 8 entire floors were simultaneously rising above it. 50. 7 meters from the ground floor all the way up to the finished roof. 8 interconnected floors effectively stitching together an entire sprawling city. 40,000 dedicated workers. 38 total months of continuous construction. Ordinary passengers walking through here every day genuinely never think about any of that effort. And in a strange way, that is exactly the point. That is precisely what success looks like for a project of this size. Blueprint approved in April of 2022. Doors officially opened on June 27, 2025. 38 total months from empty mountain slope to the largest fully operating train station anywhere on planet Earth, rising directly out of the mountains surrounding Chongqing. Welcome to Chongqing East.